A person can take vitamin D every morning, catch plenty of sun, eat all the right foods, and still see a blood test come back deficient. For many, that isn't carelessness or a lack of trying. The result was shaped, in part, before they were ever born. Because vitamin D is misnamed, it isn't truly a vitamin. The skin makes it for free whenever sunlight lands on bare arms, and the vitamin D you swallow arrives inert, a hormone waiting to be switched on. Before it can do anything, it has to be rebuilt twice by a chain of enzymes, and the blueprint for every link is written in your genes. So that blood test number is never just sun and diet, it's a readout of your own biology. That number is the storage form of vitamin D, the version that builds up in the blood and tells a lab whether you're deficient. But it isn't a simple fuel gauge, sun in, level up. Every molecule has to travel a production line whose speed is set, in part, by the genes you were born with. Change a single letter in one of them, and the reading drifts higher or lower than sunshine alone would predict. Picture that line. It opens in the skin, where sunlight strikes the first spark, then runs to the liver for a first chemical edit, and on to the kidney, where a second edit switches it on. One more step stands ready to switch it back off, clearing the active hormone before it can build to dangerous levels. Activating, storing, and clearing. 3 stations on one line, each run by its own gene. Let's meet them. It starts with a fork in the road. Deep in the skin sits a single raw material, a cousin of cholesterol, and ultraviolet B light can turn it into vitamin D. But the very same molecule is being pulled the other way by an enzyme that makes ordinary cholesterol instead. The faster that enzyme runs, the less is left to become vitamin D, so one gene can tip the balance before sunlight ever gets its chance. And presiding over all of it is melanin. The pigment that shields darker skin also filters out the wavelengths that make vitamin D, so the richer the pigment, the more sun it takes. Whatever the skin makes, plus whatever comes from food, like oily fish or fortified milk, flows first to the liver, where an enzyme tags it into that storage form the blood test reads. The blood then carries it to the kidney, where a second enzyme throws the master switch and creates the potent, active hormone. A third enzyme does the opposite. It dismantles the hormone and clears it, so levels never climb into toxic territory. The body is always switching this pathway on and off, and the genes behind those switches set how briskly each one answers. Now the single most powerful genetic lever of all. Vitamin D barely dissolves in water, so almost all of it, around 85 to 90%, travels through the blood clipped to a dedicated carrier protein. Its gene has been studied more than any other in vitamin D biology, for good reason. In one study of older adults, people who had inherited 2 copies of a single common version carried blood levels about 10 nanomoles per liter beneath everyone else, a real gap, traced back to one letter of DNA. And here biology turns into geography. That carrier gene comes in a small family of versions, and the mix you carry follows your ancestry. One version sits in more than half of people of European descent, yet is rare in people of African descent, and others run the opposite way. Across the globe, they trace a gradient from the equator toward the poles, a slow adaptation to how much sun a population gets. Where the sun is weak, the balance tips toward versions that hold on to vitamin D. Nearer the equator, it tips the other way. It also explains a real frustration in the research. A variant that flags low vitamin D in one population can lose nearly all its power in another. At the end of the line waits the receiver, the receptor that lets active vitamin D do its work, dialing hundreds of genes up and down inside your cells. One common version builds a slightly longer receptor that reads its signal a little less efficiently. So you can hold a perfectly normal level in your blood and still hear its message more faintly than the person beside you. So that number on your lab report hides a whole production line beneath it, sun and diet at the start, then a string of genes shaping every step from skin to receptor. The official guidance still hands everyone the same target, about 600 international units a day, a little more with age, a sensible baseline. But it's an average stretched across millions of pathways, and yours is unlike anyone else's. So the next time your vitamin D comes back low, the richer question isn't just how much sun you got. It's how your own biology, the genes you've carried since birth, chose to handle it.